Hi guys. So today we're going to be learning about complex numbers like it was from scratch. So all numbers can have a real portion and an imaginary portion. So let's just take a normal counting number. Let's say 2 and let this be z. So the real portion of z, because 2 is a real number, would just be 2. But the imaginary portion, because there's no imaginary portion, it would just be 0. However, if you took another number, something like maybe z equals to 3 plus 4i, where I kind of denotes the imaginary portion, you could say that the real portion of z would be 3, and the imaginary portion of z would be 4. And take note here, you remove the I when saying it's like imaginary because it's not needed. And these will be the types of questions you may be asked. Okay, the next really important thing when it comes to complex numbers is what is a conjugate of a complex number. So conjugate. So if we say maybe z equals to 5i plus 4, the conjugate is the expression very similar to that one, but where the sign between the real portion and the imaginary portion is flipped. So it'd be 5i minus 4. So take note here, if you have multiple terms, maybe 2 imaginary terms and 4 real terms, you may want to group them together, remove the I or factorize out the I in order to distinguish where the conjugate sign must be placed. Okay, so the main types of questions they might ask you is almost an evaluate. Okay, so let's say z equals to 2 plus 3i and w equals 5i minus 4. So they might say x is 3w plus the conjugate of z, and they want you to solve for x. So this is really simple, and you kind of want to treat the I, while it might be intimidating, as some sort of like an algebraic variable just for easiness. So you might want to just substitute those w and z conjugate. So just like an equation, you want to put the 3 on the outside of the bracket. Sorry about that. 2, so it would be 5i minus 4. And we know the conjugate of z, you just flip the sign, so it's plus 2 minus 3i. And be really careful to put brackets over here, especially if this sign was a minus. So you can continue expanding the brackets just by using the normal rainbow method. So x equals 15i minus 12 plus 2 minus 3i. So then now you just want to group all like terms. So you would have 12i minus 10, and that would be your final equation for x. So as you can see, imaginary and complex numbers are really similar, and the main use for them you can see is when if you're graphing and the graph doesn't really touch the x-axis. So there you can say b squared minus 4ac, aka the discriminant, would be less than 0. And while you might have thought this has no solutions, it does. It has imaginary solutions. And usually the imaginary solutions will be both of the conjugates of each other. So thank you.